Thank you very much. Okay, so this is in the context of the Advanced Software Design Techniques course in the Master in Software Engineering Information Systems in UNIBZ. So in this course we talk about different software design techniques to do evolutive design, to learn how to use patterns in a combined way to drive your design. So the idea is for the students to, in conjunction to Open Data Hub, so work also with real data. And sometimes it's kind of really easy when you, let's work with toy data, and then we have a few records and just a few fields, and then, now let's face, for example, the mobility API, which has a lot of stuff we need to understand how to interact and how to deal with that. So the idea is this partnership with the Open Data Hub that we can even, where is Stefan? That we can announce that today we do have an official partnership with the university was signed today. So we already had this initiative last year, but this year maybe we can say this presentation is the first after the agreement. So it's always very positive for the students also to work on with real data and try to implement. Last year I was more specific about the challenges. This year the idea was to let the students kind of choose what they are going to do, so they have contact with some of the APIs of the Open Data Hub, and I left for their imagination to what they could do, right? So then the idea, the format we are going to do here today, it's similar to last year. I will each group will do like a short presentation, something from 3 to 5 minutes to kind of introduce what they did, and in the back they have some posters that have some more details, right? And then they will be there. So the idea is that they are going to first, all of them will come and present this introduction, and then we are going to have the poster part in which they are going to be there, and then you can go around and talk to them and maybe get more details as how they did some stuff. So and then there is this more interactive part. So I will call the first group. I will use the order that is in my machine, so not very specific. Okay, so let's start with a framework. Don't forget to present yourselves. Hello. Come there.
I'm Özgün, and I did a little Java library for simpler open data API integration. So the reason is now, I think the most difficult part of using Open Data Hub is to set the requests up and then the methods and everything. So if you can abstract it away, then I guess it would be a good idea. And to be fair, I also didn't want to work on front end. And so I built a library. It provides two functionalities. One is sending the request, and the other is to build a querying syntax for the Open Data Hub. If we were to use it, then sending the request and getting the response would just be this line. So I think it's simpler than setting it up by hand, maybe in Java. And this is the return result. This is the object, ODH entity. I'll get into the things later. Yeah, as I said, it provides two functionalities, query and request center. And let's see how they're used if you were to use the library first. Also, I forgot to mention, I created like an Open Data Hub entity object, which kind of represents the response structure. So again, now if we use the library, then we don't need to map it to our custom objects and etc. So that logic is also averted. Okay, let's begin with the first part. How do we use it? I have a class named ODH client. It's a singleton. I get the instance of it. And with a method call, I make the request. This is the data type, mobility type. Oops. And depending on the type, ODH client is like an adapter. It uses the correct client object to make the request. And it's like a easy to use, fluent interface. Yeah. I think we talked about these parts. And the second part is the query generator that we pass into the HTTP request strings. I kind of got the idea from the JPA interface. We need to extend the ODH query generator interface provided by the library. It's an empty interface. It's used as a marker. And depending on the method name, we get the request generated for the thing. You can see the created string there. Like that's the result of this call. Okay. So we need to extend extend the interface, and then using the factory, which is a dynamic proxy actually, get an object that can actually build the requests upon method invocation and actually create the string. Yeah, that's it. And it has some standards, unfortunately, we need to follow. It has to start by find by, and then the field name that we want to query for, and the operation equals, etc., whatever the Open Data Hub provides. How did I implement it? I can explain to you next to my poster, because let's not take too much of a time, and that's it for my project.
Okay, as he said, you can ask for more details than in the poster session. Is there anyone hungry there?
So I have the notes here, but nothing is so.
Yeah, so you coordinate. Don't forget to present yourself.
Wait, I need my notes, or else I'm just. Let's just rub it. Okay.
Hello.
Hello, we are. It's fine. Hello, we are Be Hungry. We have another teammate, but he couldn't be here today because he had to work, so it's just us here today. Okay, so our agenda today is we will introduce our project to you, and then we will talk about the technologies and the software development techniques we use, and then we will show you the APIs that we used on it today. Firstly, what is Be Hungry? Be Hungry is the platform to introduce people to the restaurants around South Tyrol area, and it's also going to give you useful information about how to transport to these restaurants. We use mainly JavaScript-based technologies. We used React.js, Next.js, TypeScript, and Node. And also we used for testing the Jest framework. About the APIs that we used, we mainly worked on the gastronomy API, as you see in the screenshot there. It was the main functionality to show the restaurants around the area, but also for the mapping functions, we use the charging station IPs and the parking station IPs. We also tried to implement bus stations, but it didn't work well with the rest of our data, so at the end of the day, we didn't end up using that. And we also use these design patterns, and yeah, that's all things.
Great. I want a lot of more details in the poster station. The flight planner. Don't forget to talk close to the mic.
Yes. So my name is Mattia, and me and another guy, Isa, by searching on the Open Data Hub data that was available, we chose to analyze the flight dataset. I really like that flight dataset because I also know other applications that have the same functionality of recording and following the flights inside an airport, but also in real time. So that's why I chose the South Tyrol flight planner, since also we have the airport near here. So our key features that we immediately wanted to implement inside our software were the first one, displaying flight status from or to South Tyrol. The flights that were starting from here, Bolzano, or were coming from another city or another country here in Bolzano. And the second feature, so this was arrival or departures variables. And the second one was filtering flights based on flight type, ticket type, etc. The types meant, for example, which ticket are you buying inside a plane? For a standard, for a child, for an adult, or a basic ticket, a go ticket, a quick one, or a basic one, or a premium, and so on. The various type of tickets that you can buy inside an airplane. So these were the two main functionalities that we wanted to add inside our software, our website. So we started, this was my part, and the front end was done by Isa. So starting from the back end, languages and technologies used, I mainly used the language Java and uses the framework Spring Boot. These two on the left side are the two choosing sections inside the UI in the website, in which the user could choose, for example, the flight type and the ticket type. The flight type, which, as I said at the beginning, could be or arrival or departure or both of them, and in filters where or all the four or the ticket basic, light, plus, and go. So these were the four options. And the black image, it's shown because I had in the backend section create a structure, a principle by composing the HTTP website in the local machine. That's why it's written 8080. In which I had to show to the front-end part, for example, type equals arrival and ticket equals plus. So I had to variables already chosen, which were the same that the user chose by his hands in the front-end part. So I had two filters, and this is an example of the data from the backend that was thrown to the front-end that he had to take and convert it into some front-end UI that the user could see more functionality, more functional, not only black and white like it's in the backend part. So I used these two languages and frameworks. In the front-end part, ISA used the frameworks and languages here written, Byte, Next, and the TypeScript. This is an example of the UI that in the website is shown to the user that it's using this website and want to analyze the flight data that it's available inside its application. Here are the filters that I spoke about it before, and these are the flight list that the user could see when choosing the flight he wants to analyze. For example, here I put the flight type all and ticket all, but by choosing the flight type departure, here I can see always from BZO, which means that Bolzano is the departure, it's the starting point. Or otherwise, arrival means to, it's always Bolzano. And these are the two main filters. And I cannot explain much more about the backend, the front end, because I never used these tools. But my mate used these ones, so I haven't really deep inside this part. But the other functionalities that we wanted to add, I'll explain here at the end of the presentation, which are adding new filters. As I shown before, these are the main filters that we already added inside the software, but we could add many more. For example, even the starting date to the from date to day, which is the period of time that you want to analyze the flights. So this could be another filter. But yes, adding new filters based on the price, per adult, child, infant, or the period date, and so on. And the second one is receiving more detailed data from Open Data Hub API, still the flight dataset, which is flight delays, real-time announcement, notification, and so on. But there are many variables. The only difficult thing is to implement inside the backend part and throw it to the front end. But this is the main principle about our flight application related to the Bolzano airport that we extracted the data from. So, thank you.
Recipes.
Hello everyone, I'm Matteo, he is Matteo, and we are going to present our project that is about a traditional recipe of South Tyrol. And we wanted to build a full web application where we basically list the traditional recipes that we get from the Open Data Hub API. And to give more value, we added the functionality of looking on the near shops in order to find basically the ingredients of the recipe. So the users can see the recipes and look for the nearest shops in the area. In this way, we want to promote the local shops and to promote even the traditions of South Tyrol. Now I'll give the mic to my teammate Matteo.
So as for the implementation goes, we opted for dividing backend and frontend between a backend application written in Java. We used the Spring framework, and we obviously deployed everything using free tools. So, for example, for the backend we use Render. So if you try to access the front end, we'll have the link later, you might not find any data because the backend has to wake up. But yeah, we did an easy setup using Spring, the Spring JPA utility to integrate with a MySQL database that is hosted on a free SQL database website. And we deployed the backend using Docker, while the front end is written using the Svelte framework and deployed using Vercel. So the structure is pretty straightforward, let's say, and we have our backend and front end which are deployed separately, and we have the free SQL database running in the free SQL database website. And we, as soon as the backend starts, we fetch the recipes or update them, we fetch everyone. Then when a user visits the website, they can scroll through the different recipes, maybe filter for something they want to search, and then they ask also, for example, to find shops in their area. They can provide their geolocation, so that and also the distance, the radial distance in which they want to find the shops around them. And because of this, then the front end queries the back end queries the Open Data Hub, and filters based on obviously grocery shops, and then Matteo is also going to tell what we wanted to also achieve, what can also be achieved onwards, let's say, with this project.
So basically, we also have some future ideas on that. We want to filter the shops based on the ingredients we want to buy, by mapping the ingredients to the shop, maybe using AI, and yeah, there is actually a lot of future ideas that maybe I will tell you on our stand. Thank you.
Thank you.
Now the last group.
Hello. So today I'm going to present our project, which our team built, Isadora, Saif, and Harshal. So our project combines two APIs, so the weather API and the bike API, and the goal was to create smart recommendations for users. So, okay, so the goal was to combine real-time weather data with bike availability for smarter bike rentals. So it provides a weather-based recommendation on where and when is it best to rent a bike. So in terms of features, so we have a weather part where we can see current weather with a 5-day forecast, then real-time bike data availability at different stations across different districts in South Tyrol, and of course we combine those to get better recommendations in terms of weather and bikes, let's say. And of course, we integrated distance mapping to suggest the best stations to the users according to the distance. So yeah, as already mentioned, we use two key APIs, the weather API and bike API. So in terms of integration and processing, so we, the system, let's say, maps weather with nearby bike stations, and it acts as a, let's say, advisor on what is the best place to rent a bike, yeah, in terms of distance, weather, and yeah, that's all. Yeah, in terms of visualization, we created a user-friendly web application that the users can interact with. And why this project matters, so it offers better user experience. So yeah, imagine you can always know which bike is available. Then of course you're aware of the weather, if it's a good choice or not to ride a bike. Then in terms of recommendations, yeah, suggest the best stations to rent bikes based on weather, distance, and availability. And most importantly, it supports sustainability, so encourages cycling, and yeah, it helps the planet get better one ride at a time. And yeah, that's all.